Hi all, let us see how to determine the Laplace transform of this given signal x of t, a into u of t. Also let us find out how to determine the region of convergence. X of t is equal to a into u of t. It is given in the problem. When you represent any signal a into u of t or any expression multiplied by u of t, it is normally considered as the expression only for the time duration from t greater than or equal to 0 onwards. So to find out the Laplace transform of the given signal, normally we used to consider the formula integral minus infinity to plus infinity x of t into e power minus st dt. But the given signal is available from 0 to infinity. You can see that the range of the signal is only from 0 to infinity. So that too, the signal is simply a DC line, a constant. So when you substitute into the formula, it will become a into e power minus st dt. If a is taken outside of this integral, this will simply result in e power integration of e power minus st dt, which will be simply written as a into e power minus st, right, e power minus st divided by minus s, where the lower limit is 0 and upper limit is infinity. When you substitute like this, it will simply become e power minus st divided by minus s. Isn't it? E power minus st can be written as Laplace transform of the given signal x of t, which is equal to Laplace transform of a into u of t, which is actually identified as e power minus st divided by minus s, where the lower limit is 0 and upper limit is infinity. As you all know, s is a complex variable which is sigma plus j omega. If this is also substituted into this equation, the Laplace transform of the signal a into u of t will be identified finally as e power minus sigma plus j omega into t divided by e power minus st divided by minus s, isn't it? Lower limit is 0 and upper limit is infinity. Substituted. Now let me try with the limits. The Laplace transform of the given signal a into u of t, simply rewritten as e power what is it? E power minus sigma plus j omega, and if you substitute the upper limit, it will become into infinity divided by minus s minus lower limit. When it is substituted in the place of t, it will become e power 0. Correct? Now the same problem can be finally concluded as by decomposing the real part and imaginary part of the exponents. Now you can find out this will become e power minus sigma into infinity into e power minus j omega into infinity. To determine the ROC, we just go for this kind of calculation. E power 0 is 1 and 1 by s it is. So this is the result what we have obtained for Laplace transform of the signal a into u of t. So let me rewrite it once again. A into u of t is equal to e power minus sigma into infinity e power minus j omega into infinity divided by minus s plus 1 by s. This is what we concluded just before few seconds. Now let me take the real part alone. When sigma is greater than 0, positive quantity, that sigma is a positive quantity, e power minus sigma into infinity will become simply e power minus infinity, because it is a positive, sigma is a positive quantity. E power minus infinity becomes, it will become e power minus infinity is, what is it? It is equal to 0. When sigma is considered to be less than 0, e power minus sigma into infinity, sigma is a negative quantity, so it will become e power plus infinity. So this is written as, what is the result of it? This will be equal to infinity. So which is not supposed to be the condition for the existence of Laplace transform. This must not exist. Which must not exist? Sigma less than 0 should not appear into the conditions. Therefore I can say like this: x of s converges only when sigma is greater than 0. So the condition can be written as or can be shown as a graph sheet, isn't it? As a graph. In a graph sheet you can just mention the boundaries of it. I just take sigma in this axis, j omega in this axis and sigma in this axis. 0 is considered to be present here, and we talk about the condition sigma is equal to 0. Yes, that is called abscissa of convergence, isn't it? For the values of sigma greater than 0, something happens. For the values of sigma less than 0, the x of s will not exist. So abscissa of convergence is called right? I'll show you that. So x of s, what is x of s? X of s is written as a into e power, when sigma is greater than 0, what happens? A into e power minus infinity, that becomes e power minus sigma into infinity, e power minus j omega into infinity divided by s, isn't it? Minus s was there, and the result is appended with one more. What is the term that was existing in the result? This is 1 by s also. So let me conclude like this: this will become 0. If this becomes 0, then the expression will get reduced to a by s alone, right? X of s, I just write it as the final answer when x of t is equal to what is it? A into u of t, which is considered to be a for the values of t greater than or equal to 0. In such cases, if you apply Laplace transform on this following, on the signal, that is Laplace transform of a into u of t is considered to be a divided by s, only the second term appears only when x of s converges for the condition sigma greater than 0. So the ROC, Laplace transform of a into u of t, is a by s. With ROC, this condition is, this result is true only when sigma is greater than 0. So let me write it like this: Laplace transform of a into u of t is equal to a by s, right? With ROC. What is the ROC? ROC is the set of all points in the S plane. In S plane, we have seen it in the diagram, graph, to the right of the abscissa of convergence, to the right of the line passing through, sigma is equal to 0. Sigma is equal to 0. So ROC is the right half of the S plane. What is ROC? You can state like this also: ROC is in the area which is covered by sigma greater than 0, or you can mention that it is the right half of the S plane. It is right half of S plane. right? That's what we have shown here, that this is the ROC, this is the ROC, the area, right? So this is one of the important things that you must know when you work with Laplace transform. I just move on like this. When the x of t is given as a t into u of t ramp signal, we could understand that this is simply t only for the values of t greater than or equal to 0. How to find out the Laplace transform of the signal given? And you must also determine ROC of the signal. Let me start with the solution. How will you apply Laplace transform to a given signal? Laplace transform of any given signal is considered to be, or is calculated, determined using the formula integral minus infinity to plus infinity x of t into e power minus st into dt. Okay, now what is actually x of t in this case? It is minus infinity to plus infinity t into u of t e power minus st dt. Since u of t is available here, as we mentioned earlier, you can simply reduce the condition to 0 to infinity t into e power minus st dt. This is actually the Laplace transform of the given signal t u of t. In such case, how will you determine? You have to consider the formula for or you have to simply compare this with the situation u into dv. What is u? I should imagine some terms which are present the integration as u. I just take u is equal to t. So du hereafter will be simply du will be simply hereafter 1 only, right? Similarly, what is considered to be dv? I just take this as e power minus st. So v will be hereafter, by integrating on both the sides of this small assumption, v will be equal to e power minus st divided by minus s, isn't it? So when with these two assumptions, let me rearrange this expression. What is x of s? Let me determine. X of s is the Laplace transform of the given signal. What is the given signal? Laplace transform of t into u of t. Right, this is identified. Still now, what we have assumed, it is in a situation where 0 to infinity and it is actually t into e power minus st dt. We have made some assumptions. I have told you already, u is equal to t and du is equal to 1. V is considered to be simply e power minus st, dv is considered to be minus e power minus st. So v will become e power minus st divided by minus s only. So when I use those conditions into the formula u into dv, I can say uv minus integral v du is the formula. You have to substitute into this condition to find out what is x of s. X of s is will become simply t into e power minus st by u into v, t into e power minus st divided by minus s, correct? And the other one is minus integral v du. What is v? You have to mention about it. What is v? Integral e power minus st divided by minus s. What is du? V du. It will become simply, right? It will become simply dt, isn't it? So the lower limit still remains the same. Upper limit is infinity, 0 and infinity. So in such situations, when you apply the upper limit, this will become simply, the expression will become, what will become, when you apply the lower limit and upper limit into this expression, you will find out, you can even isolate those two expressions separately, these two components separately, and you can substitute upper and lower limit. T into e power minus st, even minus s can also be converted into sigma plus, what is sigma? Yes, what is s? S is equal to sigma plus j omega. So when you substitute it, it will become e power minus sigma plus j omega into t divided by minus s remains the same. 0 to infinity, lower and upper limits. whereas the integration of this one will result in e power minus st, right? St divided by, already s was there, minus s is there, and multiplied by minus s, it will give you s squared. Lower limit is 0 and upper limit is infinity. So this is as of now, and I have already told you to make some changes in s. S can be substituted, s can be simply replaced as sigma plus j omega. So upon making those substitutions, this will simply become, I'll show you the other one. What is x of s? X of s is equal to upper limit. When you substitute upper limit in the previous term, this will become infinity, right? So let me try. Infinity multiplied by e power sigma into infinity, e power minus j omega into infinity divided by minus s, first term. Upper limit is substituted, minus lower limit. When you substitute, it will become 0 multiplied by e power minus j sigma 0, it will become e power 0 into e power, right, minus j omega into 0 divided by minus s, whatever it may be. When something is multiplied with 0, the entire term becomes 0. Upper and lower limit of the first term is substituted. Just verify. This part is over, and let me now take the second one. When you take the second one, already minus is present, and you have to take the upper limit and lower limit in those places. So this will become e power minus s is replaced as sigma plus j omega. So sigma into, right, it becomes simply sigma into infinity divided by, and e power minus j omega into infinity divided by a squared. Upper limit is substituted. The lower limit, when it is substituted, it will become 1 divided by a squared, isn't it? E power 0. So it will become simply 1 by a squared. Upper and lower limits are substituted. Now the entire expression will become, or will get reduced into, I'll show you. This is infinity multiplied by, right, infinity multiplied by e power minus sigma infinity minus j omega into infinity divided by minus s, okay? Whereas the second term is actually 0. Why should I consider? And when I multiply the minus inside, it will become e power minus sigma infinity e power minus j omega into infinity divided by s squared, and the final term will become 1 by s squared, isn't it? Now you can find out that the terms will become like this, isn't it? This is the Laplace transform of t into u of t. Now you can take some conditions, because you do not know what's going to happen for this term, whether it will become infinity or, because e power minus sigma into infinity is the term which will determine the result of this x of s. Whether x of s will exist or not will be determined only from the value of e power minus sigma into infinity. In such case, I am going to just consider a situation where when sigma is greater than 0, what's going to happen? Let us verify. That is, sigma is equal to a positive number. When sigma becomes positive number, e power minus sigma into infinity will become e power minus infinity, simply because infinity multiplied by a positive number multiplied by minus 1 will become e power minus infinity only. So that is equal to 0. If sigma is considered to be a value lesser than 0, that is sigma when it is negative, you can find out e power minus sigma into infinity will become e power infinity, which will result in infinity, isn't it? Therefore, we can say that x of s converges, exists, will get finite value only when sigma is greater than 0. When sigma is greater than 0. When sigma is greater than 0, x of s will become, what is x of s? X of s will become infinity multiplied by e power minus sigma into 0, isn't it? Just recall, e power minus sigma into infinity, e power minus j omega into infinity divided by minus s was there, isn't it? And the second term that was 0, isn't it? You can just see that it is 0. Now it becomes the other one. What is the third term that has to be taken into account? Now you have to consider only the value for this. So that is minus e power minus sigma into infinity, e power minus j omega into infinity, e power minus st divided by s squared, isn't it? the final term is 1 by s squared. You can notice when what is the condition? The existence of ROC or the existence of Laplace transform is possible only for the values of sigma less than 0. If sigma is less than 0, this term will become 0, isn't it? This will become 0, correct? And this will also become 0. Now the result will become simply, I'll write it here itself, it will become 1 divided by a squared. Laplace transform of t into u of t is equal to 1 by s squared, provided the ROC is sigma must be a value, sorry, what is the condition? Sigma must be now I should take this as sigma so I can put it in this way: when sigma is greater than 0, I'll mention like this. When sigma is greater than 0, I can notice that the e power minus sigma into infinity becomes 0, e power minus sigma into infinity becomes 0, then those two terms will vanish. The final answer will simply become 1 by s squared, where the ROC is the set of all points which are available in the right hand side of the S-plane, one half of the S-plane, positive half of the S-plane, are the area or the set of all points which are available within the boundary. The boundary is the line passing through sigma is equal to 0. Abscissa of convergence is actually sigma is equal to 0. When sigma is greater than 0, I can say that the ROC is and the positive half of the S-plane. So Laplace transform of t into u of t is another important result which you must remember for some time. Okay, right. Let me move on to the next problem. What is the Laplace transform of, say for example, e power minus some value, I'll take it like this. Laplace transform of x of t is to be determined in this problem, where x of t is equal to, I'll say it is e power minus 6t into u of t, right? As you all know, e power minus 6t u of t can be written as e power minus 6t only for the positive values of t, and x of t is a causal signal. For such signal, I am going to consider the Laplace transform, or I am going to determine the Laplace transform. So let me start with the solution here. In the solution part, I must first of all write the formula for obtaining the Laplace transform of the given signal. What is the given signal? The signal is e power minus 6t u of t. Yes, it is written here, and in the formula you can notice that this starts from bilateral Laplace transform formula, minus infinity to plus infinity, x of t into e power minus st into dt. Now the given signal is available only for the positive time limits of the t. It's a causal signal, so I'll say e power minus 6t into e power minus st into dt. So this becomes simply e power minus of s plus 6 into t divided by minus of s plus 6, where the lower limit is 0, upper limit is infinity. This gives me the value of x of s, right? I'll put it in elaborate format like this. X of s is equal to e power minus of s plus 6 into t divided by minus of s plus 6, where the lower limit is 0 and upper limit is infinity. Lower limit is 0 and upper limit is infinity. As you all know, s can be replaced by its original format. S is a complex frequency variable which is sigma plus j omega. When you substitute it, this will become e power minus of sigma plus j omega plus 6 into t, and divided by the denominator s term will normally be considered as s itself. Only there is a situation where we are supposed to substitute S by its original format of sigma plus j omega representation in the numerator terms alone. So this will become x of s is equal to, what is x of s? X of s is equal to e power minus sigma plus 6 into infinity, e power minus j omega into infinity. While you substitute upper limit, the lower limit will become e power 0 divided by minus of s plus 6. You can notice that this is equal to simply, right? Before finding out the condition, I'll just want to assume certain conditions. What will happen if sigma is greater than minus 6? When sigma is greater than minus 6, then the sigma plus 6, which is considered to be sigma of minus 6, as a positive quantity. When this becomes a positive quantity, e power minus sigma plus 6 into infinity will become e power minus infinity itself. So e power minus infinity is simply, as you all know, this is equal to 0 only. So this is when this term sigma is greater than minus 6, the first term will become 0, isn't it? This will become 0. When this becomes 0, then e power 0, isn't it? The entire term, the remaining result will be 1 divided by s plus 6 only. X of s will become simply 1 divided by s plus 6, right? Needless to say, what will happen if sigma is less than minus 6? Then e power, I'll mention it in a different way. Sigma minus of minus 6 will become simply a negative quantity. If this becomes a negative quantity, e power minus of sigma plus 6 into infinity will become e power plus infinity. E power plus infinity is infinity. So you cannot have the x of s because everything else will become infinity. So that's why I say sigma greater than minus 6 is considered to be the condition for the existence of x of s. That too, x of s will become simply 1 divided by s plus 6. So this is called region of convergence, where the value of x of s will exist, will have some value as 1 divided by s plus 6. If you ask me to plot it in a graph sheet, I am ready to show you in an S-plane graph sheet like this, where I'll simply take a line passing through sigma is equal to minus 6, and I'll show you the set of all points. These are all the region. This is the region in which the set of all points of s, for which the Laplace transform of 1 divided by s plus 6 will exist with a finite value. I'll write this as, say for example, ROC. This represents ROC in an S-plane representation. So this is the line passing through sigma c is equal to minus 6, right? This is the area which is shown as ROC with abscissa of convergence for when x of t is given as e power minus 60 u of t, isn't it? When x of t is e power minus 60 u of t, x of s is equal to 1 divided by s plus 6, such with the condition sigma must be greater than minus 6. Then only this result will hold good. The x of s will converge to a finite value. So you can just make a comparison and find out what are the relationships available, right? So I can, in general, I can represent like this: e power minus at u of t will have Laplace transform x of s is equal to 1 divided by s plus a, with the ROC sigma greater than minus a. One of the general notations that I wanted to make. Thank you.